familiar with a geoboard? Do you know how to use it? Today, we learn how to use a geoboard and get familiar on how it makes math easier. In this session, we will do the following. Revisit the origin and historical development of geoboards. Differentiate the types of geoboards. Look into the applications of math in which geoboards could be of help. Use geoboards to find the areas and perimeters of polygons. I have with me a 14 by 14 square geoboard. It has 196 nails, forming 169 squares. Geoboard is a manipulative used in mathematics classes. This is often used to explore the basic concepts of geometry, specifically in areas and perimeters of polygons, like triangle, square, rectangle, and other polygons.
Did you ever wonder who popularized the geoboard? It was popularized and invented in the 1950s by the English mathematician and pedagogist Caleb Cattegno. The geoboard has been used to teach about shapes, angles, and number patterns among others in 1954. By 1970, the use of the geoboard already reached the United States of America and was used in the teaching of a wide range of mathematical topics such as plane geometry and many more. In 1990s, most geoboards were already made of plastic and were intended for use by young children. The example has a 5 by 5 square array of pegs on one side. On the other side is a circle of 12 pegs as well as a central peg and a peg near each corner. There is no maker's mark. The object was one of a set of 7 geoboards that was sold with activity cards, rubber bands, and teaching notes for $39.95. It was used in a first grade classroom at Long Latch School in Westport, Connecticut. Schools these days make modifications to include using woods and nails. 3 types of geoboards are now being used: the square, the isometric, and the circular geoboards.
There are various applications in which the geoboard is of use. One is on finding areas and perimeters of polygons using the square geoboard. So how do we find the area? By area, we mean the number of square units contained in the figure. When finding the area, we consider one little square as one square unit. Hence, in a 13 by 13 square geoboard, there are 169 possible square units. There are 3 ways of finding the area using the geoboard. First is the fill and count. Second, by halving. And third, the surround and uncount method. Let's discuss them one by one. Fill and count. In this method, one would fill the area inside the object and count how many squares were included inside the object. As you can see here, there is a square surrounded by a blue rubber band. You would fill this into smaller equal squares that will fit inside these squares surrounded by the blue rubber band. As we count how many smaller squares fit on the bigger square, we have 4 smaller squares. Therefore, the area of the square is equal to 4 square units. If we use the formula in finding the area of a square, which is squaring the length of a side, we get the same answer. This method can also be used in other polygons like rectangles, rhombus, and many more. There is another type of finding the area in square geoboard which is called halving. In this method, diagonals must be present. One counts the number of square units a diagonal is passing through and then divide that by 2, thus halving it. Example, as you can see here, we have a triangle surrounded by a yellow rubber band whose diagonal goes through 6 square units. So, therefore, the area of this triangle surrounded by the yellow rubber band is 6 square units. But as I said a while ago, we have to divide it by 2. Therefore, the area of the triangle is equal to 3 square units. If we use the formula in finding the area of triangle, which is 1/2 times the number of square units of the base and the number of square units of the height, we'll be having the same answer. Another example would be when you have a diagonal passing through 2 square units. But as I said, we have to divide it by 2. So the area of this triangle surrounded by a red rubber band is equal to 1 square unit.
Surround and uncount is another method of finding the area in this square geoboard. In this method, one would surround the entire shape and find the whole area. Then, one would count the area that is not included within the shape and subtract it from the whole area. For example, we have here a hexagon surrounded by a green rubber band. We also surround the entire shape of this hexagon by a yellow rubber band. Then, we count how many squares are included in this shape surrounded by this yellow rubber band. As you can see, there are 6 square units in the whole area surrounded by the yellow rubber band. However, 4 of the square units are using half of the unit. So therefore, 2 units are outside of the hexagon, and if we subtract this from 6, it will be equal to 4. So, the area of this hexagon is equal to 4 square units. Aside from getting the areas, another use of the square geoboard that we are going to discuss today is to find the perimeter of polygons. For example, as you can see on this square geoboard, there is a square surrounded by a blue rubber band. Let's assume that the sides of the square have 4 units each. To get the perimeter of this square, we just count how many units are here in the sides of the square. So by counting, there would be 16 units. Therefore, the perimeter of the square is 16 units. If we use the formula in finding the perimeter of the square, which is 4 times the number of units or sides, we get the same answer, which is 16. Next that I will show you is on how to find the perimeter of the triangle. This is similar to the finding the perimeter of the square. We just count how many units are there on the sides of the triangle surrounded by this rubber band to obtain the perimeter. So if we count, we get 12. Therefore, the perimeter of this triangle is 12 units. Another is finding the perimeter of a rectangle. As you can see on this square geoboard, there is a rectangle surrounded by a green rubber band. To find the perimeter of this rectangle, as you can see, the width of this rectangle is 3 units and the length is 6 units. If we use the formula in finding the perimeter of a rectangle, which is twice the width plus twice the length, we get 18. But if we use this square geoboard to find the perimeter of this rectangle, we just count how many units are there on the sides. Therefore, the perimeter of this rectangle with 3 unit width and 6 units length is 18. We use the same method for finding the perimeter of other polygons.
Thank you for listening. We hope that you learned how to find the area and the perimeter of different polygons using this square geoboard. We hope you have fun. To the teachers and future teachers alike, we hope that you will spare time to use the the Geoboard as a manipulative, especially in letting the students understand the concepts of areas and perimeters. Geoboard activities are an interactive way for students to learn about polygons and explore the world of geometry. Specifically, it will help students practice determining the area and perimeter of various shapes. These activities will keep students engaged and provide them with this entertaining way to learn about geometry.